let's talk about how you can work with Instructlab in watsonx.ai using the command line tool. So far, we have configured the model we would like to tune in Tuning Studio, and we have selected Instructlab as our tuning method. And we also have configured the GitHub access for Instructlab to access our taxonomy repository. Then we can choose to work with the command line interface. If you have tried the user interface approach, you probably would agree with me that it is very intuitive to work with, but the command line tool will be a more developer-friendly option if you want to reproduce or automate the whole process, especially if you're going to run the same configuration multiple times. And I can tell you that it's not that difficult to use the command line tool at all. Once you click this tab, you will see all the commands you need to run for this Instructlab job. A great news is that all the environment-specific variables like the project ID or the secret manager URL or service instance ID, things like that, they have been pre-populated for you in this command. So it should be easy for us to follow the process step by step. And if you are not familiar with command line tool, don't worry, I have created a few Python helper functions to help you follow along. Let's take a look at this command line one by one. First step is to assign access policies required by the backend services. The first policy is to give watsonx.ai runtime write access to the cloud object storage bucket where all the project data is stored. And the second policy is to give the runtime read access to our secret manager instance, which stores our personal access token for our GitHub repository. If you're using the Taxon Instructlab environment, the admin has run these two commands for you for this specific sandbox project. That's the reason why we would recommend you create your own tuning job in the sandbox project instead of creating a project of your own. So if you're using the Taxon Instructlab environment and you're working in the sandbox project, you can skip these two commands. Otherwise, if you are working in another environment, please make sure your admin has run these two commands and created these two access policies for your project. Next step is to authenticate with the command line tool. If it is the first time you use this command line tool, you will have to download the command line from the GitHub repository. This download helper function will help you download the command line tool from the GitHub repository based on your system. And the command line tool will be extracted from the download file, and then it will be ready for your use. Then once you have the command line tool in your environment, you can run this configure profile function. In this function, you can define the profile name and provide the IBM Cloud API key. When you execute this function, it is equivalent to running this command line in the terminal. The third command is to extract document from PDF files. It says optional here, but this step is required if you're adding knowledge to the taxonomy. If you run this command, it will convert your PDF files into Markdown format, which then will be used by Instructlab as the grounding documents for our knowledge data generation and eventually the tuning job. So if we run this command with our helper function, it will create a document extraction job. And if we grab this job ID and plug into the next function, we will get the job status. I created this job earlier. That's why the state now shows as complete. If you check on the job status right away, it will show as pending and then completed. One thing to note is that based on my testing, you do need to add your PDF to your project for this to run successfully. So at the time it says pass to the PDF file here, it really means that the PDF needs to be in the project. To prove my point, now I'm showing you my project assets, and here is the PDF document I'm pointing to in my document extraction job definition. If your document is not in the project yet, you could simply upload your documents for using this Upload Assets to Project button. Next, we can finally move on to step number 4, which is to import our starter model taxonomy from our Git repository. And if we run this successfully, the model taxonomy tree will be saved as an asset in our project. So let's run this command with our helper function. And it says we've successfully created the taxonomy. If we check our project again, you will see that the taxonomy has been created in our project. If we click on this taxonomy, we will see the visual representation of our starter taxonomy we created in our GitHub repository. You can tell here all we have is the taxonomy tree structure, but we don't have any knowledge or skills defined in this taxonomy yet. Now let's move on to the next step, which is to add our seed examples to this taxonomy tree. Now we are at step number 5. We're going to define new knowledge or skills and add it to our taxonomy tree. In order to do that, we need to create a file in JSON format that defines the knowledge or skills that we would like to add. Good news is that Tuning Studio provides sample input for both knowledge and examples for adding new skills. So we can just pick the one that we're going to add. In my case, I'm going to add new knowledge, so that's why I'm going to reference the first example. I have copied and pasted this example into my own environment on the right, and I have filled in my own content, especially in the seed examples section. Per requirement, since we're adding knowledge, so our seed examples needs to have context and question and answer pairs. In my case, my context are tables from the consolidated financial document of a public company. And for each context, I've provided questions and answers around the information presented in these tables. For knowledge definition, the context and the question and answer pairs combined are considered as one seed example. So I provided 5 examples or together. And I believe that's a requirement in the UI as well, if you choose to define knowledge in the UI. And other important fields you need to replace with your own value is the path in our taxonomy. We will put our examples in a new subcategory called finance inside the root directory of knowledge. Next, we need to replace the commit ID as it says here in the example In order to find this commit ID, you need to go to your Git repository and locate the markdown file inside this wx_doc_extractions folder. Remember earlier we submitted a document extraction job. What happens behind the theme is that it will convert the PDF file in your project and put that file in markdown format in this path of your Git repository. So click on this folder and locate the markdown file of your source document and click on this file name. This is my source document, by the way. It contains a lot of financial statement tables, look like this. And in our seed examples, all we did is just to grab some tables from the document and provided a few questions and answers about it. On this page, you can click on this commit details. And this is where you need to copy your full commit ID. And then you paste it in your seed examples JSON file. And in the patterns, you need to provide the name of your markdown file. And in document outline, you can provide a short description of what you're trying to do with this document, or a high-level overview of what the information contained in this document. And in domain, we put it finance because we will be putting it in the subcategory of finance. Once you replace all the fields with your own content, you have the seed examples file ready in JSON format, and we can move on to add this example file to our taxonomy. To do that, we need to first grab the taxonomy ID. Click on the taxonomy in your project. You can find the project ID in the taxonomy info page. This is ID for this taxonomy, and we need to copy and paste this taxonomy here and provide it to our function. Basically, we're telling the underlying command line that which taxonomy we would like to add this example file to. And this is the seed examples we just worked on, and it contains our seed examples and information about our source file in our Git repository. And if we run this, you'll update the attributes of our taxonomy as an asset in our project. If you would like to check if the seed examples are added correctly, you could run this get asset detail function. It will produce a JSON output file. So if you review this file, you will realize that our seed examples have been successfully added to our taxonomy. Another way to check is you can check on the taxonomy in your project, and then you can see that it has been modified a moment ago just because we have run this update asset attribute function and have our seed examples added to this taxonomy. Since we have completed step number 6 here, now we can move on to step number 7, which is to run synthetic data generation job. And this is the phase when Instructlab will use our seed examples to generate enough synthetic data to tune our foundation model. So we run this command with our helper function. At this point, all you need to do is to give this job a name. And once you run this, the next cell will pick up the job ID. And then with this job ID, we can check on the job status, which look like this. Same as before, if you check the job status right away after you create the job status will be either pending or running. you just need to wait for a while and the job status will change to completed. You can also find some metrics from this data generation job. Based on our seed examples, Instructlab has created 5,000 examples for knowledge and 350K examples for skill training, and altogether we've created more than enough examples to tune our foundation model. Now we are at the final step, which is to run the Instructlab tuning job. And from the previous synthetic data generation job, we will grab the ID for the training dataset, and then we will provide this ID to the create fine-tuning job function, along with a custom tuning job name, and you can also provide a description for the tuning job. And you will see that a tuning job has been successfully created. And then you can grab the ID from this output. And with this tuning job ID, you can check on the job status using this get fine-tuning details function. And as you can see here, this is a result from my previous round. It took me around 28 hours for the tuning job to complete. So definitely don't wait up, just check back later and the model will be ready. Just to show you an example, so this is a project where I fine-tuned a model using the same dataset, and by the time the tuning job show as completed, you will find the tuned model showing up in your project. And from here, you can simply deploy it within the project for testing purposes, or you can promote it to a deployment space and deploy it from there. So let's try deploy in project. And we will give this deployment a name, and there's two configurations for our model. An extra small instance will be good enough. So let's try this. Now our tuned model has been deployed, and for your reference, it takes me 11 minutes for this deployment to be ready and online. So if you click on this deployments, on this page you can find the inference endpoints, and you can test the endpoint right away, or you can test this model in PromptLab. So here I already populated a testing example. I provided the context, that is something the model has been trained on, which is to look at some financial statement table and answer some questions. So here I'm asking, how did the profit change over the years? And let's see how the model answers that question. Yes, so the model managed to answer in a format that we trained the model on. It's exactly what we expect. Just for your comparison, for the same question, if I use a model that haven't been trained on our financial documents, the answer will look like this. It managed to get the answer right, but it also goes on to create more question and answer pairs based on our context data. So in summary, in this video, I have shown you how you can use a command line tool with our helper functions to run the Instructlab process in Tuning Studio.